Hey everyone, I think we are live. Thank you so much for joining us for Lakehouse Chronicles episode 5. We'll get started in a minute or so, and we'll just give it a couple more minutes for our users to join in. Let us know where you're joining in from today, and if you're already aware of Apache Hudi or Lakehouses in general, put us on the LinkedIn comments, and we'll take questions towards the end, also like asynchronously on LinkedIn. So feel free to post it out there as well. All right. Let's see. All right. I can see people joining in. All right. I think we're good to get started, and people can join in as they come. So once again, thank you so much everyone for joining us for the fifth episode of Lakehouse Chronicles with Apache Hudi. With this new series that we started last year, we have always tried to bring exciting talks and content for the Hudi community. And then typically, we have discussions on critical topics, go over architecture internals, do some show and tell, any new projects from the community, any some interesting tips and tricks from our members, PMC members and contributors. And there are some other things that we are also planning to do as well in this particular episodes and sessions. So overall, the idea is to make things easier for developers and users to get started and use Hudi in their Lakehouse workloads, right? So, irrespective of if you're an already experienced Hudi user or contributor, or someone who is completely new to the entire space of lake houses, and specifically, you want to learn a little bit more about Apache Hudi, what it brings to the table, you should be able to find a lot of beneficial content over here. Another important note is that this is a live session, of course, but we will also have a recorded version of it. So that way you are free to explore them afterwards, or in case you cannot join the live ones. So my name is Dipankar. I'm a staff data engineering advocate at OneHouse.ai, where I contribute to open source projects like Apache Hudi. Today, I'll be your host, and today's episode format will be slightly different. Like I said, we always like try to bring in newer content and newer way of describing things. So today we are going to have a one-on-one chat with Hudi PMC member, with whom I will introduce in a couple of minutes. And we are going to talk a little bit about the newly released Apache Hudi 1.0, which is very exciting from a feature perspective, from some design perspective. All right. So with that, let's welcome Sagar. So I'm going to add Sagar to stage. Hey, Sagar. Thank you so much for joining us today for this interesting talk.
Yeah, hi Dipankar, and thanks everyone who has joined this talk. I'm so glad to be here as well.
Yeah, I know it's a bit late for your side, but hopefully the community can take a lot from this session and, and the time itself. And I'll let you introduce a little bit more for people who are unaware of your contribution. I'm pretty sure a lot of people are aware of the contribution itself as well. Yeah.
Yeah, I think I've been contributing to Hudi since past 3.5 years or so, and I work as a software engineer at One House. And I just fell in love with Hudi when I learned how under the hood it manages updates so fast, and it's not just a table format at the end of the day. And there are so many things that it does out of the box. I come from the OLTP world, and I was able to quickly relate it to the database, what databases actually do, and that love just grew stronger and stronger as
I'm
my
sure.
time with Hudi kept growing. Yeah.
Yeah. I'm sure those database principles, and I think those current internal specifics, I think they relate a lot to Hudi, and that's what kind of I also talk a little bit more about when I talk about Hudi. It's not just about the format itself, but also like the end to end, like your storage engine, your other components with like table services and stuff, which is very unique to Hudi. So we'll get to that point. I know, of course, we have a lot of interesting questions. So for viewers, just a reminder, this is like a fireside chat between us. Sagar has some presentation, but it will be basically a way to support his voices in a way. And yeah, I think Sagar, if you want to like start sharing your screen, you're free to do that. But I'll throw out some questions for you, and we can chat it formally, informally, however we like to. But the idea is that we want to know a little bit more about Hudi 1.0. You got so much of effort from the community perspective. Unique contributions, a lot of industry first features as well. So it's really exciting, even from my personal interest point of view. So I think it's a good way to show the community these things that we have developed.
Oh, absolutely. I did assemble together a few slides, but I like this Q&A format much better.
Awesome.
I'll share the slides so that it's easier to show certain things. When we are in person, we are whiteboarding, then
Yeah.
it's a whole lot easier that way.
Right.
But then slides will just do the job for us just
Absolutely.
fine.
Yeah. Right. Yeah.
Let me
Cool.
see if you can. Um,
Yeah, I can see
all
your
right,
slide.
I just fired up the
Perfect.
slides. Is
All right.
cool. Yeah.
Cool. So I think we will get started with something which is really like the foundation of Hudi itself. And I'm talking a little bit about the timeline, right? So tell me a little bit about the new kind of designed LSM style timeline here, right? It we know, of course, like it features, it kind of powers right now so many critical functionalities like the timeline itself, and it's so the foundation itself, and for the community itself, like it's super important like to understand like what's going on with the timeline, even for debugging and that
Yeah.
kind of purposes. So tell me about some of the goals behind this new timeline, right? And how is it going to be beneficial for users?
Oh, timeline, as our users already understand this, it's like the backbone of whatever Hudi does. So it's kind of like the event log, which tells you what changes the table has gone through, what files have been touched, and that event log essentially sort of forms um, uh, uh, um, like in databases, you have kind of a redo log using which you can stitch together, oh, what actually happened on the database, um, and using which different writers or readers can reason about what's going on, and the nice guarantees that you get, isolation guarantees that you get, would not have been possible without it. That's what similar role the timeline plays in Apache Hudi. Um, and uh, with the timeline that we have, which tells what kind of action is going on, whether it's in flight or whether it has completed, with that timeline format, we have been able to support not just regular ingestion writing, but
Mhm.
also some async compaction uh, um, using multi-version concurrency control.
Mhm.
Uh, but we wanted to go beyond that. Um, we will be talking more about concurrency control later on. Um, but basically, the way the timeline has changed in 1.0 is uh, to be able to support ordering based on when a write has completed. So we have added something called completion time to the
Mhm.
timeline,
Okay.
completed instant, and writes are serialized based on that. Uh, and the layout of the timeline itself has changed.
I see.
So if you recall, the way the timeline is structured is something like, let me go to the. Uh,
Mhm.
so today, we have this dichotomy of active and archive timeline,
Yeah.
and active timeline. Um, the main idea was that we wanted to keep the active timeline metadata to be bounded, so that we just load some bounded amount of metadata on the critical path. While let's say your older versions of data have been cleaned up, then we can archive certain
Yeah.
older instance, right? Um, that has worked pretty well. Uh, but in 1.0, apart from the concurrency control that we'll discuss about, we
Yeah.
also wanted users to have the capability of being able to time travel far back uh, in the history. So that meant that we need to be able to store the timeline in a more compact manner. And
Yeah.
that's what led to this LSM tree style timeline. So LSM trees are these nice data structures, which is used across many key value data systems, where you start with the data that is actively needed, and then lower down the levels of the tree, you keep compacting more and more data. So similar strategy here. For example, let's say if you're having commits every minute for the past 10 years, those can be a lot of commits, right?
Yeah. Yeah.
Um, so at the root level of the tree, we store what um, is needed right away. So for example, let's say you have these 200 instance. So you've got these 200 instance individually here. Then as we go down the tree, we compact some of uh, these instance, for example, 101 to 110 into a Parquet file, 111 to 120 in another Parquet file. That's
Mhm.
at level 0. Then at level 1, you have got from 101 to 200, 201 to 300, so and so forth. Um, Now, for time travel, let's say you want to look back at much older time. You don't really have to load each and every instant from the top level. You can instead jump back to the node which coincides. Say you wanted to time travel back to T250, right? So
Yeah.
you come to this level of the tree, get the compacted timeline for the 101 to 200, and then maybe level above between 200 to 210, 210 to 220, and so on, right?
Right.
Um, so this unlocks much more efficient way of doing time travel,
Hmm.
and it also helps with non-blocking concurrency control, which we'll maybe talk about a
Yeah.
little bit later.
Got it. I think that that balance is also super important, like you mentioned earlier, right? Having that active timeline, we want that, history to be fast. But of course, with the archive timeline is expensive sometimes, and, for, more excessive reads and writes. So I think
Yeah.
with a higher write throughput, of course, like, so I think that balance is also super important. I think that kind of also tackles this kind of problem in a way, right?
Oh, absolutely. Yeah, exactly. And uh, readers would like to learn more about this, there is LSM timeline class in Hudi code.
Mhm.
We do support reading this timeline in different modes. So not only so up until 0.x, when you wanted to read the timeline, you had to read everything in
Yeah.
any particular commit metadata. But now we have, I guess, three different modes where, let's say, if you just want to know for many of the operations in the hot path, all you care about is what is the action, whether it's a commit or delta commit
Right.
or replace commit, and you want to know when it started, when it completed. For some actions, you want to know what files it touched.
Yeah.
Rarely do you need to know, okay, what were the number of inserts or updates to any particular file. So we have a light mode for accessing that timeline, and
I
then of
see.
course the full mode where you can get everything, every information about any particular commit metadata, and
Got
that can also be configured. So there is just this another knob to
Yeah.
for users to, depending on their use case or whatever they need.
Awesome. Yeah. Good to check the class out as well in case people are interested. I can post it out later as well. But also, like with the adoption law of like the true time generation, right? You guys have adopted that as well. So
Yeah,
talk to me a little bit more about that. We know true time from probably like Spanner, right? The Spanner paper, and how kind of like
yeah,
it's becoming more generalized in a way. Yeah.
yeah, yeah, absolutely. And that ties to the non-blocking concurrency story
Yeah.
as well. So true time generation, if anyone has read about it through Spanner, Google Spanner um, paper, or maybe they wrote about in blog as well. Essentially, if I had to summarize it in a nice, crisp way, it's a way of being able to generate globally monotonically increasing timestamps.
Right.
That's what true time is all about. Now, Google, um, at Google scale, Spanner getting used for all sorts of transactional OLTP workloads. It's very, very important that guarantee is as accurate as possible, and they employ, not only software level tricks but also hardware level tricks.
Right.
Now, mm, I mean, making sure that clock skew is as minimal as possible using GPS clocks. Uh, what we have is not something as sophisticated as that, but then we don't really need it, right? So uh, what we have right now is more akin to a very lightweight distributed lock.
Mhm.
So when we generate any instant for the timeline, that you can imagine um, going via a distributed lock, um, and multiple writers will see a monotonically increasing sequence of timestamps.
Right.
So the, the semantics of true time API, we are able to achieve that suffices the use case for Lakehouse workloads,
Got it.
right? Um, so and the way that so let me uh, go to concurrency control. Um, yeah. So like I mentioned earlier, right? We want to be able to serialize the writes by completion time.
Hmm.
Um, so it's very, very important that we generate these uh, instant times, both when they start as well as when the commit is about to get completed,
Hmm.
in a monotonically increasing manner. And that's where our true time like APIs come into play. Um, it's a very lightweight, just for generating that instant, there is a lock involved, but throughout the commit, there is no lock involved. Um,
I see.
I'll get into this
Perfect.
NBCC
Yeah. Yeah. As we
non-blocking
get in
concurrency
there.
control
Yeah.
a little bit later.
Awesome.
Yeah,
Well, thank you for that additional context in there. And I think, yeah, I think we are, going to like see a little bit more applications of that, the timeline and how it, powers that in a later
yeah.
phase. But, going to the next part of it, like, indexes, right? Wow, a lot seems to be happening with indexes in Hoodie. And let me remind our kind of viewers that indexes are really an industry first thing in the Lakehouse world, right? Of course, with databases, we have had indexes as a storage access structure. But with Hoodie, we have had indexes from day one, right? And now with the already existing indexes such as Bloom filters, record level indexes, we now have the secondary and the expression indexes. So Sagar, tell me a little bit about them. Maybe you can segregate the secondary and expression part. Give our viewers some kind of an idea and how they can be beneficial in a way to them.
Oh, this is my favorite topic. I mean,
Yeah.
just that's one of the main reasons I fell in love with Rudy.
Right.
When I read about other competing formats, I mean, the first thing when you do an update, right? You just you want to do an update or delete. in a fast way, the very first thing that hits to your mind, even as an engineer, um, or simply user, is how do you efficiently locate those records, right? Where
Right.
you don't want to scan the whole data to be able to figure out, oh, this is where I need to go ahead and do the update, right? You
Exactly.
want to be able to locate them very efficiently. And as you said, Hudi had indexes from day one, which helped us do that. It had Bloom filters. Even to this day, we have Bloom filters in the footers of the base file
Yeah.
that Hudi writes. So not only that helps with the locating the information quickly, it also reduces the I/O cost. We can skip certain files that we don't really need to
Yeah.
touch at all. Um, so up until 0.x, we had um, Bloom filters. And in point 14, we actually added very powerful record level index,
Yeah.
RLIs. Um, mm, so Hudi metadata table has all these different kind of indexes. So till 0.x, we had files. Files is nothing but um, uh, telling you what partition has what files. And then there is file level statistics, Bloom filters telling you uh, Bloom filter can need not necessarily be on record key. It can be on any other key as well.
Yeah.
But basically, it's a probabilistic way of telling whether something exists in this particular file or not. And then record level index is specifically about the record key, the primary key field, which tells you directly, oh, this particular record key is associated with a particular file ID. Hudi has this very important key invariant that record key maps to a particular file ID, right? Even
Yeah.
if you receive updates for the keys, the file ID doesn't change. You could have a newer version for that file ID, but then the file ID still remains the same. So this invariant is maintained, and it's very, very important for supporting fast updates.
Yeah.
Databases have this, right? So 1.0, we have added few more statistics, uh, pretty interesting ones, which kind of also pivots to how databases do things. Just to name a few, there
Mhm.
are expression index, secondary index, partition stats index, apart from what you see here.
Yeah.
And we'll talk about how they help us uh, as for different use cases.
Awesome.
One interesting thing I want to talk about is so you can, of course, use SQL to create and drop your index that we have added. Plus, uh, we have also added support for async indexing. We had async indexing even in, I think async indexing was added probably in point 11 or point 12,
Okay. Yeah.
somewhere around that time. But all these indexes, right, they can be created via the async indexer. What that means is you can let your ingestion job do its job. The indexer in the background will build the index for you. You don't have to worry about
Mm.
updating the indexes, stopping the pipeline, building and
Right.
updating the index.
Yeah.
So that's pretty interesting. Concurrent indexing,
Yeah. Yeah.
to be short.
Awesome. Yeah, maybe let's talk a little bit more about like the newer one, like the expression one, and then a
Yeah.
little bit about secondary as well. Yeah, later. Or if you want to go the other way around, that's fine as well. Yeah. Yeah.
Yeah, all right. Yeah, let's start with secondary index. That's something most of us are familiar with. After primary key
Yeah.
index, most of us are familiar with secondary index, right? So very simply, it's an index on non-key fields. Suppose you created this table and you had primary key as UUID. Uh, but now you see that the query workload has a lot of queries with filter on, let's say, city. And y- you want to improve the query performance with such predicates, right? Then very similar to databases. All you got to do is you create index, give your index name on your table using secondary index. So this is what the syntax looks like today.
Okay. Yeah,
You specify this using clause using secondary index on the column name. All right.
got it.
And under the hood, the way it works is the secondary key maps to the primary key. So a prerequisite for this is that you have the primary key index as well,
Yeah,
the record level index. And then the primary key maps to the file ID or to which this particular record key belongs. Now, when a query comes like select, let's say, rider driver, you want to look at all the rider drivers in a particular city, where city is equal to San Francisco, then uh, our query planner, we have our own. So for instance, for Spark Engine, we extend the rule API, and we have our own file index that plugs into the um, uh, yeah, optimizations query planning phase before the cost-based optimization kicks in.
right.
There, we are able to identify from the predicates that okay, this is something where we can use index, um, and we will look at the secondary index stored in the metadata table, be able to skip a lot of files based on that index, and serve the queries. So that's secondary index. Like I think conceptually it's pretty
Yeah,
simple. I just threw in some diagram here to show under the hood what we store
yeah.
actually on storage.
Awesome. And this index also, like both secondary and expression, like they are supposed to sit as like the partitions in our internal MOR Hudi metadata table, is it? They still are.
Absolutely, absolutely. That's the beauty of it, right? We are not using any other database or any other key value store
Yeah,
to, back our indexes. They are nothing but Hudi merge on read tables.
right.
The metadata table that you get inside dot Hudi slash metadata under the base path. This secondary index is a different partition within the metadata table, and it's managed. By managed, I mean the updating of index itself is very similar to how any merge and read table
Yeah.
is handled in Hudi.
Awesome. Yeah. I mean, it's great to see how this generic kind of like multimodal like indexing subsystem that you kind of like originally like thought about and like designed about have been like instrumental in adding this new different types of indexes, right? And that's the beauty of it.
Exactly. And before we talk about expression index, you brought up a very key phrase,
Yeah.
multi-model indexing.
Yeah.
And I think everyone gets the idea, at least in the Hudi community, why we call it multi-modal indexing. It's not just the indexes are not just helping us with
Yeah.
file listing or just with locating records based on primary key efficiently, but there are many different use cases, as we'll see in expression index. I'm very excited about expression index as well. That's
Yeah.
something first of its kind in the Lakehouse community, at
Exactly.
least.
No,
Yeah.
let's talk about it directly. Like, let's go into it and like talk about expression index since we are here already. Yeah.
Yeah. So the idea for expression index, again, inspiration from Postgres. They have indexes on expressions. But the high level idea, if you think a little bit more deeply about partitions, um, why do people create partitions? Sure, it's a convenient way of storing your data. You can uh, um, that is there, but the main thing is that you want to be able to prune partitions when your queries come along.
Yeah.
Um, and as and when there is a lot of talk about hidden partitioning and evolving the partitions. Say
Correct.
you started with the month level partition and today you want to change it to date level partitions. So the key thing to understand there is partitions are just another way of coarse grained index. at the end of the day, what do indexes do? They help you
Yeah.
locate something efficiently, right? So that's what the partitioning also does. So we can subsume the use case of partitioning into index itself. So what
Nice.
I'm showing here in diagram is, let's say your uh, storage partition was actually by city, and then later you wanted to going back to the same table. So the table is similar. You have a TS column here, which is nothing but a huge. It could be here. It's a string, so it could be uh, date string uh, with HHMM seconds
Sure.
format,
Yeah.
or think of it if you are just having epoch timestamps, so
Yeah.
a long value,
Long
right?
value.
Um, so the Spark or most SQL engines already support certain expressions on such kind of data. So, for example, the Spark supports from Unix time on the long value epoch timestamps. You can specify the format that you want, and this function will basically extract the particular date string in that particular format.
Hmm.
So instead of repartitioning your data, what you could do is you could create an expression index. Um, Syntax is very user friendly, just like
Yeah.
create index SQL syntax. Or you again need to use the using clause to tell, oh, you want to collect stats on it. So expression index can collect stats as well as create Bloom filters. It's very powerful. Here I'm showing an example of column stats, but in the documentation, Hudi docs, you'll see that you can create Bloom filters as well on expressions of columns.
Yeah.
Um, so now when a query comes along in the query planning phase, we again see, um, okay, this even though storage partition is not on the basis of a date string, but we do have an index m- which is collecting stats aggregated at this particular date string. So using those stats, we are able to prune the partitions. So
Right.
all in all, the expression index is a very powerful index that helps you um, not only subsumes the role of partitioning, but also, even if your data is non-partitioned and you do want to accelerate certain queries which involves expressions, even then you could use expression index.
Awesome. I think even from a like the usability perspective, right? That's what I'm thinking from more of a user perspective. I think the
Yeah,
way that the ability like to all of this is possible via Spark SQL, right? With like a SQL statement. So um,
exactly.
yeah, so
Yeah.
I think that that makes it super easy as well. In general. One question I was going to ask is you brought up hidden partitioning, and it's pretty much like used in other formats world. Is it like something? Would it be right to assume like that it is pretty much the same stuff that we are doing with Hoodie here with this expression index?
Yeah. So with this, the hidden partitioning just becomes a use case
Right.
um, of expression index. So, for example, notice that we did not create a physical storage partition for this
No.
date string, right? We just
Right.
built an index for it.
Yes.
Um, mm, and with the index, we are able to achieve the same effect that you would have with hidden partitioning.
Right.
Um, and we don't store, so with hidden partitioning, I think you end up eventually storing more metadata
Mhm.
as compared to what you would with an index.
Right.
Um, uh, you don't carry that baggage along. It's an index, you can use it for anything.
Yeah. Yeah. Looks
Yeah,
pretty lightweight as well. Yeah. In a way.
yeah.
Awesome. Well, we are almost in the couple like last 15 minute ish like time, but have a couple more questions. So I'm going to like dive more into the questions. I know you have to do like the major part of the speaking, but yeah, I mean, hopefully like we can bring some more attention. So let's get back to our topic of interest, both from yours and my perspective, NBCC, non-blocking concurrency control, right?
All
So,
right. Yeah.
talk us a little bit more about concurrency control. I think one way to start this would be like just to like talk about like with optimistic concurrency control and the concurrency control method that are there in today's Lakehouse table format, right? Mostly OCC,
Yeah.
and why OCC is doesn't suffice our use cases. What are we thinking from a streaming perspective? Maybe those are angles as well.
Yeah. Yeah. It's very important to understand that. So typically, you've had three approaches to deal with concurrency in data systems. One is, of course, the pessimistic, where you something like two-phase locking, um,
Yeah,
which works for workload that don't have very high write throughput, don't have very high write contention.
yeah,
Um, and it's fine. It's still out there in many systems today. Uh, but then later, community realized that okay, we don't really have to lock the whole world to complete a commit, uh, because the writes are not running into conflicts that often.
yeah.
So came along this idea of optimistic concurrency control, where you're optimistic about the conflict, that it's not going to happen very often. And if it does, we'll abort and retry the transaction.
Sure. Yeah,
That's a OCC.
yeah.
And as more advanced version is multi-version concurrency control. Multi-version concurrency control is more for data systems which do have this which do store multiple versions of the data,
Yeah,
and sort of log structured storage systems,
exactly.
those kind of systems. um, so they isolate the readers and writers by uh, telling them apart, what's changed as part of which transaction, and any particular transaction just views a particular version of the data. So for Hudi, multi-version concurrency control has been the default. And even today, when you spin up a Delta streamer with Hudi streamer for merge and read table,
Yeah.
async compaction happens in the background by default, and that the conflict between compaction and the upsert operation of the streamer is
Mhm.
handled via multi-version concurrency control.
Right.
All right, but we wanted to go beyond. We wanted to make it more and more streaming friendly. That was one motivation.
I see.
Second piece of the motivation was that uh, OCC, like its default in many other computing formats, but we have seen in production workloads, especially in cases where you have to uh, uh, a data engineering team is running a deletion job due to, let's say, to comply with GDPR norms,
Right.
while the ingestion job is running. But this deletion job is long running, while ingestion job could be committing frequently every minute or so, right?
Sure.
What we have seen in these scenarios is that you very frequently run into conflicts, and you can no longer be optimistic, so to speak, in these kind of scenarios. And you'll end up wasting compute resources just by simply aborting and retrying the transaction a lot of the
Right.
times. There
Right.
have been techniques in the literature which tells you where you can configure which transaction to abort. Maybe one transaction is more compute heavy than the other, so you can prefer a particular transaction to continue. And we do have something like that as well in the Hudi. But simply that did not suffice both the use cases, the streaming one and this long run deletion job.
Right.
So we came up with this non-blocking concurrency control. And that's where the instant time generation using true time like semantics comes into play. So
Mhm.
what non-blocking concurrency control does is uh, you just generate an instant time, and a transaction starts with that particular begin time. Even if there are conflicting writes, right? You just keep adding log files. So keep adding log files. We defer the conflict resolution towards the end, and the conflict resolution happens on the basis of completion time. So
I
it's
see.
quite possible that a transaction T1 started at a begin time, uh, let's say T, uh, I shouldn't say transaction T1. Let's say a commit C1 started at T0, T1,
Mhm.
and a commit 2 started at T2, which is later than T1, but commit 2 completes at T3, commit 1 completes at T4. Uh, so you would have added log files due to commit 1 and commit 2 both. But
Right.
then when while reading or for any purpose, you need to create. So Hudi has this concept of file slices, right? The file slicing there is done on the basis of completion time.
Yeah.
That is what essentially I mean by serializing the writes on the order of completion time. It's
Right.
the file slicing algorithm that has essentially changed based on that. So any two writers, even if they are about to touch the same file ID, they can go ahead and complete their writes. But when we read that data, we know exactly how to order um, the writes based on completion time. So you get a deterministic result based on that.
Got it.
And there is no blocking here, yeah, for high contention writes. Nah, we don't abort the transaction anywhere. If at all there is some blocking, it's just while generating those timestamps,
Got
the
it.
begin and the start timestamps.
Okay.
That's it.
And would it like also like like extending a bit to the table management services, right? For example, like compaction
Mm,
happening, right? I
yeah,
think before at least like there was this like notion, there was this no notion of like completion time at least, right? So I think
yeah.
would it be like right to say like in this under this new design, the file slicing, whatever I kind of understood, it includes only those slices whose kind of completion time precede the start of this compaction process, or compaction, let's say
Yeah.
compaction had to previously start, right? They had to wait for, if I'm not wrong, they had to wait for a certain action to be completed on that particular instant, and then it picks up the compaction process. But has that changed a little bit, or like is there a different notion now in general with table services?
I think the file slicing has changed a little bit. So previously, uh, the example that you are giving, right? In that case, when the compaction starts for a particular file group, um, uh, you are only seeing the file slices that have been completed as of when that compaction starts.
Starts, yeah.
Okay.
Yeah.
And that will write a new version of that particular file group. There will
Correct.
be a base file to that file group. Now, when that compaction is running, you could have another writer that now wants to update the records in those file groups.
Right.
So that will go ahead and write to a new log file. But then those log files will later on be part of the file slice that got generated due to compaction. Um,
Got it. Is that during
yeah,
query time or compaction time, or it does it differs to that during that
yeah,
process, or
it differs to the reading time. Correct.
okay.
Yeah,
Okay.
that happens on read.
Got it.
Yeah.
Awesome. And I can share blog later about this new NBCC design that we wrote. Also, like the RFC is like really amazing to like read through. So
Yeah,
for people who are interested, yeah,
right, right. RFC 66 for those who are interested and just, you
perfect.
know, can't wait a lot.
Yeah,
Uh,
yeah,
go to RFC 66.
awesome. All right. I think then moving on, I think we have probably like one or two more questions, and and then that's all. So one thing that kind of caught my attention was around like positional merging and partial merging abilities. I read somewhere that you were able to like do some large gain on updates with both of these capabilities. Do you have any numbers or any kind of design choices that were there as part of that?
Yeah, yeah. That's another thing that we are very excited about because this unlocks very efficient CDC updates as well. And you'll understand once you understand this, the partial update encoding.
Right.
Um, so let me start with, since you brought up numbers, uh, uh, and, uh, let me start with that.
Yeah. Yeah. We
So
have the numbers.
when and then we'll get into what partial and updates and positional merging
Sure.
is. Um, so this is mainly useful for update heavy workloads. These numbers are for base 1 TB data set, and you have 100 columns. And every time you're receiving 80% random updates for three, any random three columns. Um, and what you see on the left is update latency when you do a full record update and partial update. We'll get to the difference between them in a minute. Bytes written and the query latency when you read the data. Um, and as you can see, the update latency overall, you get 1.4x gains. But if you just talk about the what time it takes to ex ju- uh, just update. So this is an end-to-end latency. There are a lot of stages in the write path. If we do index lookup,
Yeah.
and before writing the data, right, building workload profile. Those familiar with Hudi would know about this, what we do within building workload profile. So this is end-to-end 1.4x gains. Just about writing that data, there is even more gain. And then bytes written actually on storage, that gets reduced a lot. So we have better storage utilization, and query latency has drastically improved. So the numbers wise, the gains are impressive.
Right.
Under the hood, now I'll tell you quickly what's going on, right? So Hudi had this key-based merging of records from day one. Merge on read was a first-class uh,
Yeah.
component in Hudi, and we used to do merges based on keys. Um, Apart from that, what we have now introduced in 1.0 is to record the positions of the record that are getting updated in the log file and do position-based merging. So the diagram here on the bottom right, this basically shows what's going on in case of positional merging. Um, so we record what are the in the incoming batch, what are the positions within the, you have a base file, and within the base file, you have a column chunk for C2, C4, and so on, whatever columns you have.
Mhm.
Within each chunk, you have pages. The data for the
Sure.
column is divided into pages, where these are all page offsets, and it tells you basically what particular record for that particular column is at what offset. So we just record the update vector, what has changed, and then this helps us skip certain pages here. So
Right.
we know that when in this particular log file, we see that the update vector contains 2 and 17. So for column C, pages pertaining to column C2, we can skip these pages from 6 to 15, right?
Right.
We just need to read these pages. So that is, so we basically got into the guts of the format and see what the minimal information we need to do the update. We are storing that as in the log file. And then
Right.
based on that, we are skipping more and more data and doing the update.
Got it.
So that's positional merging. what partial updates is pretty. I think I don't need to talk a lot about it, but just briefly. So by partial update, so far Hudi had been whenever an update for a record comes in, even if just two or three columns had changed out of that 100 columns wide table, we would record the full record in the log file, right?
Yeah. Yeah.
We are doing away with that and just recording what columns changed.
Got
And that is why you see this dramatic storage utilization
it. Right.
gains. Um, just by doing that, we save a lot, especially when you have very wide tables, hundreds of columns, and
Yeah.
just updating a few lower tens of columns, right?
Got it. So these are also like these are more of like, are this configuration from a user perspective, or like are they like, are there like specific like queries around this, or
Yeah, there is configuration, and 1.0 we have thoroughly tested it, and I think using record positions that is enabled probably by default. Um, uh,
okay.
uh, and I'll have to check the configurations
Sure.
page.
Yeah.
Uh, all in all, users can switch between these two different modes of doing things depending on their use case.
Awesome. I think we are on the last, a few minutes here. In general, I don't see much question, but like given the mode of a session, like I would expect like more on asynchronous side, so we can take that. But quickly, like on maybe the last thing that I wanted to like just quickly touch upon is like the merge modes and the custom mergers. So Hudi from day one has helped implement this kind of event time processing semantics, right? If you may,
Yeah,
via pre-combine or ordering fields, which is why Hudi kind of shines in those kind of workloads, stream processing workloads,
yeah.
and also to like handle late arriving data more effectively. Tell me about those merge mode, that are becoming more, I guess, first class citizens now within Hudi 1.0.
Yeah, absolutely. As you said, Hudi had um, uh, from day one something called record payload API.
Yeah,
And record payload API, together with the pre-combined field that you configure, help to determine um, what should be the order of records. Simply, could it be, for example, there is overwrite with latest, which basically says the last write wins. If you have two records for the same key while merging them, whichever was written in the end, that wins. Then there are event time based ordering semantics, but that led to sprawl of lot of record payload APIs, and yeah, for CDC workloads, we have a few different record payload APIs. Um, we wanted to unify these. At the end of the day, they are basically telling us how to merge any two particular um, records with the same key, one existing on storage and the other one that you're getting from the incoming batch. How to merge those, right?
right. Yeah,
Um, and we wanted users to give them more flexibility uh, to determine how to merge these two records out of the box. So that's what merge mode is all about. We're saying you can have merge mode, commit commit time ordering based or event time ordering, or your custom mode, whatever way. Let's say you have some special use case through which you want to tackle deletes differently. When you're merging records,
yeah,
deletes you want to tackle differently, so you can bring your own. You just need to implement this record merger API, and put your Java class in the class path, set the merge mode to custom, and Hudi will take care of the rest.
awesome.
Um, um, so all of this work being done at the API level is mainly to cater to simplifying things, and then going forward, even for CDC style workloads, uh, if you need more flexibility there, um, uh, w- w- you could use custom merge mode as well. Um, so yeah, this is more on the usage side, I would say.
Yeah.
The as a community, we have to, the three key pillars that, as we say when we discuss among ourselves. So there are three key pillars to Hudi: reliability, performance, and usage.
Mhm.
We have talked a lot about performance and reliability in the previous feature set.
Yeah.
This is more about usability. And I think this makes it more easy to adopt. First of all, understand, and then easy to adopt the merge semantics as per your use case.
Yeah, this is a great application, to be honest, and this is like, probably in my previous jobs as well, like what I have typically seen, like for example, deduplication is a great use case here, right?
Right.
And that comes out of the box, and it's kind of like I appreciate it so much, like here, because the way that logic is being handled, without me taking care as a data engineer or architect, that makes life pretty simple as well. And I kind of feel that is also like a really good aspect to think about. For people who are probably unaware in general, is that record merges allows you to like make the decision how you kind of tackle this incoming batch of record with this record that are already there in the storage, and how
Yeah.
you define that merge logic is ultimately that makes the decision. So I think these merge modes and the ability to customize these things, I think that makes a lot of great points around your usability perspective that you mentioned. So thank you so much
Yeah.
for that, Sagar. Yeah. Um, we are on the top of the hour. It has been a really good discussion. I wish we had more time to like chat in general, like more about stuff. But of course, like
Oh yeah.
yeah. I really appreciate taking the time, Sagar. Like it's I know it's pretty late already in India. I think this is a great momentum for the community as well. These are some of the really industry first features that we're talking about today. And for our viewers, feel free to like post any questions that you might have asynchronously or a LinkedIn, invite or whatever post that is, and we will be sure to like answer them and get to them. But thank you so much once again, Sagar. And I think if you have to take one particular or probably like one thing that you're currently working on as part of the stabilizing a release, or any new things that we might see with Hudi 1.0 as the base, if you want to talk about them, that's all. Yeah.
Yeah, so users can go to our Hudi website and look at the roadmap
Yeah.
of what we have in plan. But I would like to call out all these great features, right? How do users who are already on point 0.x with these different storage format changes, how do I safely upgrade to 1.0?
Correct.
So so far we have supported backward compatible reads, but now we also have backward compatible writes. And going forward, when we do, I think 1.101 patch release is on the way, should be out in Feb. Um, uh, we have, even for 1.0.0, if you check out release docs, we have upgrade protocol. Um, and we have thought about given a lot of thought to how large deployments can easily upgrade to 1.0.
Right.
Um, and to that end, we have introduced backward compatible writer. So 1.0 version, just by a tweak of config, can write in the older format as well, in 0.x format as well.
Got it.
Uh, in large deployments, it may be possible that you're not able to upgrade the binaries, the packages for all the nodes simultaneously, right? So you do rolling upgrades, keeping the writer table version as the same as what you had in 0.x. And then eventually, when the packages have been upgraded, then you turn on the auto upgrade, and then it works out of the box. So to summarize, 1.0 can read and write in both the
Both of
versions.
the- Yeah.
Uh,
Awesome.
yeah,
Awesome. Well, this is a great part as well, like you said, like for the migration itself, and that
yeah,
makes it again easy for people to like, for larger tables. It's super important. Migration is already such a scary word, like in a way. So it kind
Yeah,
of makes things super easy in a way. Yeah.
right. Yeah.
Thank you so much once again, Sagar, and thank you so much to our viewers who took the time to like just tune in, and and also you can find this session later on YouTube by next weekish, and I'll see you on the next episode of Lakehouse Chronicles. Thank you once again, Sagar. Bye.
All right. All right. Thanks a lot, Dipankar, for having me, and thanks to all who joined us live. Have a
Awesome.
great day. Bye.
All right. Bye.